Thanks for tuning into this week of Watermark Equipment Tips. Laith here. This week we're going to be discussing conductivity. Conductivity is one of the most important measurements in your process control equipment. It helps you determine when you're at your saturation point, when things start to precipitate out of suspension and start causing issues in your process, most immediately impacting your heat transfer coefficient. But what is conductivity and why does it help me? Conductivity in this industry is known as microsiemens per centimeter. Microsiemens is the inverse resistance, or how conductive something is, per centimeter is basically for every centimeter. So I'm thinking about a standard conductivity probe. It works a lot like a multimeter. Multimeter, you have a positive and a negative, you've got a predefined distance, and you're measuring resistance. If you think about a contacting style conductivity probe, you got two tips doing the exact same thing with your water. So here I have just a standard boiler probe, and all I've done is I've wired this boiler probe up to a multimeter. Now the multimeter is going to show me units in ohms, not microsiemens, but they're inversely proportional. Very, very similar. So if I have this in air, it's showing me an open loop, which would be really, really, really pure low conductivity. It's infinity here, but it would be zero in microsiemens. But now if I submerge it into my water, you're going to start seeing the multimeter respond. That's giving me a measurement in kiloohms. But again, in conductivity, that would now be a higher value. I have another style of conductivity probe. This is a toroidal style. So this isn't contacting. This has a magnetic field. And based on the intensity of that magnetic field, it's determining conductivity. So you have one half of your toroid basically as a little antenna emitting a magnetic field, and then another receiving side receiving that magnetic field. If it's a strong magnetic field, then you know you've got a conductive mix. If it's a weaker magnetic field, you're in a pretty pure and non-conductive environment. Anyway, dropping this same conductivity probe in here, you'll see the controller is reading in microsiemens per centimeter. So this is relatively low. This is just my pure tap water. It's got some dissolved solids in it, but in our application, we start dissolving solids. You dissolve solids and then fresh makeup comes in, you evaporate water and fresh makeup comes in with more solids. So I just have a tablespoon of salt here. This will probably make it pretty salty. I just drop that salt in. Mix it up real good. Now when I go in with both my multimeter driven boiler probe and my toroidal style conductivity probe, we should see different values. We've got more solids in there. So you'll notice my kiloohm value went much lower. And then similarly, if I put my toroidal probe in, you can see it's now spiked almost to 10,000 microsiemens and I'm getting a conductivity high alarm on the controller. So my conductivity on the controller in microsiemens went up by adding the salt, but my resistivity did the opposite. It goes down. More salt in the water makes the solution more conductive. You may remember in your science class, you had an electrical circuit. You put two ends in water, it was connected to some kind of power source, a light bulb, and you had water in the middle. You started adding salt, and that light bulb got brighter and brighter. That's exactly what conductivity is in our process. Why is it important? Because you can use this to map how much you're concentrating up. You've got makeup water at a certain amount of microsiemens with a certain amount of hardness. You know what your makeup pH is. You know what your silica levels are at. So you can kind of calculate, knowing the chemistry you're using, how much could I cycle up before I'm in this gray area where it's going to cause process issues. Balancing that efficient use of water with chemical consumption, and you don't actually want to cause any harm or inefficiencies in the process by stretching that too far. So that's conductivity in a nutshell. Thanks for tuning in. Hope you learned something. See you guys again soon. Thanks.